Okay, so today we're going to talk about some of the tricky things in solving a definite integral problem where you have a contextual situation. It is known that a virus spreads through the population at a rate given by p prime of t, where p is the population measured in people and t is measured in weeks since the first case was discovered. That means that the units for p prime would be people per week, because it's a rate or a derivative, and these are the units that I will need to use. After 6 weeks, there are 5,000 people infected with the virus. The first question asks, how many new cases of the virus are expected during the second week since the first case was discovered? A lot of students, when they read second week, assume that we need to integrate our rate from 0 to 2. But that would be a mistake, because that's giving new cases during the first 2 weeks of this epidemic. And that's not what we want. We only want the number of new cases during the second week. So, the first week goes from 0 to 1, and the second week would go from 1 to 2. So I'll integrate from 1 to 2 p prime of t dt, and that would give me the number of new cases during the second week of this epidemic. Here's something else that's tricky. How many people were infected 2 weeks after the first case was discovered? Now, we know that after 6 weeks, 5,000 people are infected, so the population at 6 weeks, then we're going to add the integral from 6 to 2 of p prime of t dt, and this should give us the population after 2 weeks. Now, this is a little bit confusing to a lot of people because they'll say that my limits of integration are backwards. The trick is making sure that these two always match. Well, let's figure out what's going on. Remember that if you feel as though these are backwards, you can always interchange your limits of integration, and that would cause you to subtract . And so here, if you want to see why it works out correctly, we have p of 6 and then minus. When we integrate p prime, we're going to get p of t, and by the fundamental theorem, we'll evaluate that from 2 to 6. So I'll have p of 6 minus, need to make sure I use some parentheses or brackets here, p of 6 minus p of 2. Watch your signs. You need to add the opposite here. And so p of 6 and minus p of 6 are gone, and that leaves me an answer of p of 2. And so this is the correct approach. This is the way that I should set up this problem in order to figure out how many people were infected 2 weeks after the first case was first discovered. Thanks for listening, and remember to enjoy calculus.